In this lesson, we're going to build our first class that uses the command design pattern, and the command that we're going to build is one for the player to attack a monster with a weapon. We'll start by building the command class. So open Visual Studio, and in the engine project, create an actions folder. We're going to have a lot of game actions, so this would be a nice place to put all of them. And inside the actions folder, create a new class called AttackWithWeapon. This is going to be our action class that lets you attack with a weapon. And the class is going to look like this. We have a constructor that takes in a game item, which is going to be the weapon, and it takes in the minimum damage and maximum damage. We're going to remove those properties off of the game item class and put them in here. Then we're going to check those parameters just to make sure that they're valid. Here we have a check on lines 16 through 19 that says check the weapon category and make sure it is a weapon. If it's not, then we're going to throw an exception saying the item you passed in is not a weapon. Then we're going to check the minimum and maximum damage parameters. We want to make sure the minimum damage is at least 0. You can't have a negative minimum damage. And that's on lines 21 through 24. And on lines 26 through 29, we're going to check that the maximum damage is not less than the minimum damage. So it has to be the same or higher. Otherwise, we throw this other exception that says maximum damage must be greater than or equal to minimum damage. And then we save the parameter values into some private variables we have up here on lines 8 through 10. This is going to be kind of a common pattern for how we design our actions. On the constructor, we're going to pass in any objects or information you need to perform the action, and then we're going to have an execute function that does the action. So after the constructor and the private variables, on line 12 we have a new public event called onActionPerformed, and the event handler here is a string. This is just going to be a way for our event handler to send some sort of message that the UI may care about. Here our message on action performed is going to be either you missed the monster or you hit the monster for so many points of damage. For other actions, for instance, when we have a spell, we might have a different message. When we have a potion that heals you, it's going to be a message that says you are healed for so many hit points of damage. This is going to be the common way that we send a message that the UI can actually see and display through this event on the action class. And of course, for any public event, we need to have a function that actually raises the event for anyone that's subscribed to it. That's our report result function on lines 51 through 54. It looks to see if anyone is subscribed to the onActionPerformed, and if so, it raises the event and passes in whatever message we want to send to the subscribed object. And finally, the heart of the action class is the function execute, and this is on lines 36 through 49. Every action class is going to have an execute. That's what we're going to call to do the action. And we're going to pass in here, we're passing in the actor, who's doing the action, and the target, who's receiving the action. So for this, it's going to be the actor is going to be the player, and the target is going to be the monster. And the code we have inside this function should look familiar. It's basically the code from the game session where we had the combat. We get a random number between the minimum damage and maximum damage, the values that were passed in the constructor parameters. If the damage is 0, we're going to report a result that says you missed the monster name. Otherwise, we're going to report a result that says you hit the monster for so many points of damage, and then we're going to apply the damage to the target, to the monster. If this isn't clear right now, don't worry. At the end of the lesson, after we've got all the changes in place, I'll kind of work through the flow of how things actually happen when we have the player attacking a monster. And you may notice that we have some parameters that we're not using yet. For instance, in the execute, we're passing in the actor, but we don't use the actor anywhere inside the function. And in the constructor, we pass in the weapon variable, and we check to make sure it's a weapon, and we save it to the private variable, but we don't use it anywhere in this class. But in the next lesson or two, we actually are going to use these values, so I figure we might as well pass them in now instead of adding them in the very next lesson. And you may also notice in the execute function, when we successfully hit the monster for some damage, on line 46, we report the result that says you hit the target for so many points of damage. This report result raises the onActionPerformed event notification, which is going to get back up to the UI so we can display the message in the UI. And we do that before we actually apply the damage. Again, that's because the monster potentially could be killed on the damage. You hit the monster and do the last hit point of damage to them so they get killed. And in that case, it fires off some other events that give the player the loot and create a new monster for the location. So we want to make sure we report the damage first before we possibly change what the monster is. The next class we need to work with is the GameItem class. And in here, I've added a using statement for using engine.actions because now we need to have reference to the namespace for the actions since we're going to store the action inside the GameItem class. And I removed the minimum damage and maximum damage properties and added in this new action property on line 18. Its data type is AttackWithWeapon. So this action is going to hold an AttackWithWeapon object, that new command object we just created. And then we're going to change the GameItem constructor, delete the minimum damage and maximum damage parameters, and the lines where we were assigning the parameters to the properties, and then add in this new AttackWithWeapon action parameter, and on line 28, assign that parameter value to the property. And we also need to make the change in clone so that we pass in the action parameter and we don't pass in the minimum and maximum damage parameters anymore. And then we're also going to add this new function PerformAction. So this way on the GameItem object, so it's going to be something like the weapon, the rusty sword that the player has. We're going to say rusty sword, PerformAction, the actor, the player, the target, the monster, and then it's going to look at the action object we passed in, that new AttackWithWeapon class, and it's going to call the execute function. So that's this function here in AttackWithWeapon that's actually going to calculate the damage and display any messages. And this is how we're going to use the weapon on a monster. We're going to say, on this weapon, PerformAction. Since we've changed the GameItem class, we need to change the item factory. Now we have different parameters in the constructor, so we need to make the factory work with those. In the engine factories item factory class, in the BuildWeapon function, lines 35 through 43, we now have this in two steps. First, we're going to instantiate a weapon as a game item with the weapon enum, the ID, name, price, and whether it's unique or not. We're going to save that to weapon variable, and then we're going to set the weapon's action property. This is where we create a new action object, the AttackWithWeapon object, and we pass in the weapon, the minimum damage, and the maximum damage. We need to do this in two steps because notice we're passing the weapon into the AttackWithWeapon class in the constructor. So we need to have a weapon variable and pass that in to create our action object that we assign back to the weapon action property. This isn't something that always happens with the command design pattern, and Really, I don't like doing this. At some point, I want to see if I can change this around so it's a little different. As we add more actions and we know really what has to be used, we're probably going to be constantly refactoring and changing how this works, but this is good enough to start with for now. And this is using the composition over inheritance pattern. So here we're constructing kind of a generic GameItem object, and we're passing in some behavior for that object. We're saying this object can act a certain way. For a weapon, it's going to be an attack with weapon action. For a healing potion, we're going to create some new actions in the future, and it will be heal. For food, it will be heal or maybe provide some other special effect. But this is where we're composing the GameItem object's behavior through passing in command objects. It is kind of thinking a little bit backwards, a little bit in reverse from how you might normally think of programs. But if you follow the code, and especially if you put in some breakpoints as you run this after this lesson, you'll see how it flows and kind of get a better idea of what the command design pattern and what composition over inheritance does. Next, we need to modify the living entity class. The first thing to add will be on line 101. We're going to have a new public event called onActionPerformed, and its event handler string. The way the command notifications are going to work is the UI is going to watch for actions performed on the living entity, the player object. The player object is going to look for actions performed by the weapon or by the healing potion or the food or whatever. So when the healing item or the weapon raises an action message, the player is going to catch it, and they're going to use this onActionPerformed and the associated raise action performed event down on lines 214 through 217 to notify the UI, because the UI is going to be subscribed to the player's onActionPerformed. We could have the UI go directly to the weapon's onActionPerformed, but then if we change the current weapon, we need to unsubscribe and subscribe to the new weapon, or if we change the item that the player is using for their healing potion or their food, we're going to have to manage unsubscribing and subscribing. So it's a lot easier to just have the player watch all the objects and then have the UI watch the player, and it kind of is going to aggregate or consolidate all the messages in one place. One way to think of this is like a company. A manager probably has several employees working for them, and a president of a company probably has several managers working for them. So the employees are kind of like the weapons and the potions. Whenever they have an important message, they tell their boss, the manager. And then whenever the manager has something that the president needs to know about, in this case the living entity has something that the UI needs to know about, then the manager is going to raise an event and notify that to the president. This way we can have the manager in the middle that can kind of coordinate what information needs to go up to the president and what information can just be ignored or dealt with by the manager. The next change we need to make is the current weapon's location. In the existing code, the current weapon is in the game session because the only thing that can attack is the current player, and we only care about the player's weapon. We don't have the way for a monster to have a weapon or for a trader to have a weapon. They're not going to fight back with a weapon. But really, if you think about it, the trader or the monster does have a weapon. So the current weapon really belongs in the living entity class and not in the game session. Because when a player fights a monster, the player is going to have a weapon and the monster is going to have a weapon. If the player fights a trader, the trader is going to have a weapon. So we're going to have each living entity is going to have their own current weapon. So we're going to delete the current weapon property from game session, and we're going to add it in here in the living entity class. On line 17, I've got the backing variable underscore current weapon. And then on lines 69 through 88, we have the current weapon property with the getter that returns the backing variable and the setter that sets the current weapon to the value passed into the setter, but it also subscribes and unsubscribes to and from the raise action performed event. So this way, when the player changes their current weapon, then we're going to look at the current weapon's action and subscribe to its onPerformed event. And that's the one in this AttackWithWeapon class. And this is the one that the living entity is now going to watch for events on these objects, these game items, and then it's going to throw or raise an event of its own for the UI to watch. And the final change to living entity is this new function on lines 117 to 120, use current weapon on living entity target, and this is just going to call current weapon perform action and pass in this, the living entity who's doing the attacking, along with its target. For right now, this is just going to be the player passing in themselves as the actor and the current monster as a target. But in the next lesson or two, we're going to give the monster the ability to use a command object to attack the player. So it's going to reverse the objects that are passed in. The this is going to be the monster and the target is going to be the player. We don't really need to have this function use current weapon on. It gets called by the game session class, and the game session class could just say current player dot current weapon dot perform action current player comma current monster. But I think this is going to make it a little bit clearer, so I just did this little wrapper function to make it easier for us to understand, so we're not calling current player dot current weapon dot function. That works, but I don't like the idea of going down and calling functions on a object that's a property of another object. It just goes too deep into needing to know what child objects are doing and grandchild objects are doing, so I think it's a little simpler to wrap it up this way. The next change is going to be in the game session class. Here we're going to remove the current weapon property that was at line 101, because now the current weapon is down in the living entity class. And since the game session object is going to look for action messages from the living entity, we need to subscribe to the living entity's on action performed event. And we do that up here in our current player on lines 29 and 38. That's where we subscribe to the current player's action on action performed, and we unsubscribe from the current player's on action performed if the current player ever changes. Not that I think we'll ever going to have that in this game, but it's a good programming habit. And then we need to create the on current player performed action event handler function, which is down on lines 279 to 282. And we're just going to look for the sender and then the string result, since the event passes back a string. And we're going to call the raise message function here that displays the message on the UI. And then finally, we're going to change the battle logic. In the attack current monster function, first on line 249, we need to check to see if current player.current weapon equals null. Before we were just checking if current weapon equals null because current weapon was a property in game session. Now it's a property in the living entity, so we need to just change where we're checking for it. And then on line 255, where we used to have the code that looks like this, what's on 264 through 275 right now, we're going to replace it with one line. Current player dot use current weapon on current monster. So the end result, after adding in the new AttackWithWeapon class and making all the other changes, we've basically eliminated these 10 lines of code and replaced it with 1 line of code. But it's going to provide a lot more flexibility for some of our future actions. Now, to see how this actually works in combat, the way it would work is when the player presses the use button next to their weapon when they're fighting a monster, it calls the attack current monster function. Then on the current player object, it's going to call use current weapon on current monster. So if we go into that one, this is where it's going to look at current weapon. So the rusty sword, for example, and it's going to say perform action, passing in this, and this is the player object, and the target, which was the current monster. So if we go to perform action, this is where we say on the action property, if we have an object in there, call its execute function, passing in the actor and the target, and that's going to be the AttackWithWeapon class. The execute function here gets the random number and checks to see if there's no damage, it raises 1 message. If there is damage, it raises a different message, and it applies damage to the target. We did a lot of work in this lesson, and we really haven't changed the functionality of the game. It still works the same as it did before, but what this is going to do is for the future, we're going to be able to just create a new action command object that has different behavior in the execute, and that will let us add new features to the game very easily. So our heal action is going to just need some different code here in the execute. If we want to have a weapon that does damage and heals the player, so if you hit a monster for 4 hit points of damage and you receive 2 points of healing from the weapon, we can do that very easily by creating a new command object and change the execute function a little bit, and now we've added the new feature to the game. So this will hopefully pay off in the long run. Now we need to make one last change in mainWindow.xaml on line 234. The combo box where we're showing the player's weapons and we're binding the selected item to the player's current weapon. Since we moved current weapon out of game session into current player into the living entity class, we need to change the binding to be current player.currentWeapon. After making all these changes, run your unit test and make sure they still pass, and then run the game to make sure you can still attack the monsters and defeat them and get all the messages you expect to see. If you're having any difficulty understanding the flow of this, try setting some breakpoints in the different classes. So like the game session attack current monster, and then use F10 to step over or use F11 to step into the code so you can see and follow along with how it's working. That might help you understand a little bit better. And if you have some ideas about how to make this more generic, that is definitely going to be the very next lesson, because we're going to make it so that the monster can use the same attack with weapon function when it attacks back to the player. As always, if you're watching the video on YouTube, in the description below the video there will be a link to the support page that will have all the source code, and if you have any comments or questions, you can leave them there and I'll get back to you as soon as possible. Thanks.